Hi, today's project is a spider with a procedural walking animation. Its movements are generated in real time to adapt to its surroundings, which would be infeasible to implement with traditional keyframed animations. Let's start by creating a kinematic chain for a leg. A chain is composed of a root node and any number of rigid segments, which we can render using the new block display entities. To move the chain, we will first move the last segment to the target position. Then, we will recursively move each parent segment to the base of its child. Now the chain is no longer attached to its root. We can move it back using the same principles. We will repeat this procedure until we find a solution within some acceptable margin of error. This is a commonly used algorithm called FABRIK. Currently, the joints can rotate with 360 degrees of freedom. This is fine for flexible appendages, but for leg joints, we typically want to restrict them to only rotate on one axis. To apply this constraint, I straightened the chain towards the target before applying the algorithm. Here, I created a spider with 4 chains for legs. Let's accelerate the body forward. If each leg gets too far away from its rest position, let's tell it to return to the rest position. Let's also make sure that the adjacent legs are grounded before we start moving each leg. Right now, the spider will stand in awkward poses after coming to a rest. Let's decrease the trigger distance while the spider is standing still. One other issue is that the legs will phase through each other if the rotation changes too rapidly. We can interpolate the rotation gradually across multiple frames. Next, we could tell the spider to stop moving if its legs get too far away from their rest position. Right now, the spider can only walk on a flat plane. To fix this, we can scan a column of blocks to find the ground height and use that as our new rest position. We need to move the body as well, so I averaged the position of all the legs, added a small offset, and used the result for the body position. Next, I would like the spider to respond to gravity. To add this, we will accelerate the body downwards. If the spider has at least one pair of opposite legs on the ground, we can apply an upwards force to counteract gravity. For the final challenge, I want the spider to be able to walk on these discontiguous pillars. This is impossible with our current strategy, as the spider's legs won't be able to locate the ground while passing between gaps in terrain. To fix this, we could try scanning the 8 neighboring columns as well and picking the one closest to the rest position. However, this created a new problem, since the legs would now prefer moving half a block to the adjacent columns instead of stepping up one full block. To address this, I set the comparison point half a block above the rest position if the path is obstructed. Lastly, I want to mention a bit about the block display entities I used to render the spider. In Minecraft, all entities can rotate onto axes. They have a pitch, a yaw, but no tilt. This is a problem for the lake giants, since every time they cross over the y-axis, they would rotate 180 degrees in order to reorient themselves upwards. Here's what that looks like in context. Thankfully, the block display entities allow us to specify a custom transformation matrix. This means we can rotate them using a matrix with an arbitrary up vector instead of the usual rotation component. I used the cross product between the y-axis and the end effector, since that always faces the same direction. Here are some variations I was able to create by changing a few parameters.